Hello everyone, and today's topic is OOPS concepts in Python. Python is a multi-paradigm programming language. It supports different programming approaches. One of the popular approach to solve a programming problem is by creating objects. This is well known as object-oriented programming. So, major principles of object-oriented programming is given below. Object, class, method, which we talk about these things in the previous session, and inheritance, polymorphism, data abstraction, and encapsulation, which we will talk about these in detail. So in Python, the concept of OOPS follows some basic principles. Say inheritance, the process of using details from a new class without modifying the existing class. So coming to encapsulation, hiding the private details of a class from other objects. Polymorphism, the concept of using common operations in different ways for different data inputs. So what is inheritance in Python? As the name suggests, this concept is about inheriting properties from an existing entity. This increases code reusability, and Python supports single, multiple, and multi-level inheritance as well as hybrid inheritance. So let's take an example for single level inheritance. So person is a class here, and this is a base class. And employee is another class which is inheriting properties from a base class person. So this is how we inherit a base class. So let's go to the Python console. Say class, person, say name Ravi, and write a method, say def get age self return 35. Write one more class, say employee, which is inheriting properties from a base class person. Write a default constructor in it, and pass it, and try to create an object emp is equal to for the child class. So we created an object emp for employee, which is inheriting properties from the base class person. So when you try to do emp.name, it inherits this class variable name. So the output is Ravi. The same way, when you try to inherit emp.getAge method, so by inheriting properties from the base class, we will be able to get all the properties from the base class to the child class. This is how the single inheritance works. In the same way, multi-level inheritance. In this example, manager inherit properties from employee, and employee in turn inherit properties from the base class person. So there is three level of inheritance, so it's called multi-level inheritance. So coming to multiple inheritance, here you can see entrepreneur is one of the class which is inheriting properties from the person as well as employee. So there is multiple inheritance. If you come from a Java background, Java do not support multiple inheritance, whereas Python supports both multi-level as well as multiple inheritance. And coming to the hybrid inheritance, combination of single, multi-level, multiple and hierarchical inheritance is known as hybrid inheritance. So in hybrid inheritance, the method resolution order is decided based on MRO algorithm. So it follows DLR, depth first, left to right. That is, child will get more priority than parent. So left parent will get more priority than right parent. So we define MRO for any class by using MRO function. So syntax will be class name dot MRO function. Use the priority list. Let's go to Python terminal. Say class take another class B, which inherits from base class A. Take one more class C, which inherits from A, B, comma A. Take one more class D, which inherits from C. So classes A, B, C, D forms multi-level inheritance, where C, A, B forms multiple inheritance. So class name dot say D dot MRO function returns me. It says D is given high priority than C. So child class is has more priority than the base class C. And from C, its left parent is has more priority than the right parent. So B is has more priority than class A, and the default object as a superclass. So C dot MRO method returns me C as a child class, followed by B, B class and A class, followed by object. You can notice here object is a superclass for every class. And let's take one more example for hybrid inheritance. We have a class A, class B, class C as base classes, which have method M1 and a print statement in each of the classes. And we have a X class inheriting from base classes A and B. And we have one more method M1 which prints X class method. Similarly, a class Y which inherits from B and C, and class P which inherits from X, Y and C classes. So we shall try to run in the Python console. Just copy this, open the new console. So we are trying to create one object for class P. So when you try to call M1 method with P object, it says P class method. So when you try to do class name.mro, gives me a method resolution order for the class P. We can clearly see this says P class has higher priority. So this method will be called when you try to do p.m1 method. So in a similar way, we can also create one object for y. Say y is equal to capital Y. So when you try to do y dot m1 method, gives me y class method. So y dot mro gives me method resolution order for class y. Sorry, capital Y dot mro. You can see here capital Y class has higher priority than B, C and object. This is how the resolution of method takes place in hybrid inheritance in Python. And coming to the next topic, super function in Python inheritance. What is a super function? It allows us to call a parent class method from a child class. So when you are trying to call a parent class method from a child class, we use super function. The instance function is used to determine if an instance is also an instance of a certain parent class. Is subclass function checks if the object argument is a subclass of a class. So let's take one example. So you can see here X is a child class which is inheriting properties from class A and class B. Try to do is subclass of capital X comma capital A. It gives me a boolean saying its value is true. Similarly, when you try to do is subclass say X inheriting X and the base class has C, it should return me false. This is how we use is subclass function, is instance function. Try to check an object Y for the class Y. It should return me a value boolean with true. These are the two important functions which will be helpful for our Python inheritance oops concept. So how to call a method of a particular superclass? So we can use the following approaches. Superof, this is a superclass, and self followed by a method name. So it will call M1 method of a superclass D. And coming to super function, there are two major differences between Python 2x and Python 3x. Python 2.x and Python 3.x. In Python 2.x, super has syntax like superof, subclass, comma, instance, dot method name. But in Python 3x, you can directly call using super without having to mention any subclass or instance dot parent class method. This is the major difference between Python 2x and 3x when coming to super function. So let's take few examples of self function. You can see here we have a parent class called bird, and it has one constructor which is having some print statement, and who is this method, and some print statement, and one more method called swim, and a print statement. So we are having one child class called penguin, which is inheriting from the bird class. So penguin class has a constructor which is calling the base class constructor. So superof init method calls the base class. So whenever the statement runs, output of the statement prints this print statement. So it will print bird is ready. So after that, and again print statement. So whenever you create a object for this child class, so piggy is equal to penguin, it goes to this constructor, and after this constructor it will again calls to the base class constructor. So output of this will be bird is ready, and penguin is ready. So when you try to call this method inside the child class, it prints me penguin. So again, when you try to do piggy.swim, it will inherit from the base class, so swim faster. So piggy.run gives me run faster. So you can see here piggy.swim is missing from the child class. Piggy.swim method is missing from the child class, so it will go and search for the method in the parent class. So you can see here there is a method called swim, so it will inherit these properties inside this child class. So take one more example. Say we have a class, base class vehicle, which has methods start and stop. with some print statement inside those methods. So we have one more class called two-wheeler, which is inheriting from the base class vehicle. So it has a method say which is calling the super function with start method from the base class. So whenever the statement runs, the output of the statement will be it will try to get this method from the base class. So starting engine will be printing here. So here super.stop. So whenever the statement is called, it will go and get this method from the base class. So def of stop method prints me stopping engine. And this is the output for this child class. When you try to call this method, say obj is equal to two-wheeler. So obj dot say prints me starting engine. I have two wheels and stopping engine. And this is all about inheritance and super function in Python. So going back to OOPS concepts. So next in our list is encapsulation. What is encapsulation? Hiding the private details of a class from other objects. So what is public, protected and private attributes in Python? Here name is public. These attributes can be freely used inside and outside the class definition. Underscore name. When you give underscore some variable name, it says it's protected, meaning attributes should not be used outside the class definition unless inside of a subclass definition. Naming convention as underscore variable name. The type is private. This kind of attribute is inaccessible and invisible outside this class. It's neither possible to read nor write in Python. These are the naming conventions we follow in Python to declare a variables as public, protected and private. Let's take an example for this encapsulation. We have a base class and I have a constructor inside the base class, and we have defined few instance variables, say self dot underscore parv is equal to I am a private string. The same way, one more instance variable underscore prot I am a protected string, and self dot pub I am a public variable. Take one more class. Inside the class we have a constructor and a protector method as well as private method. Go to Python console. Let's create this class A. So when you try to create an object, say A is equal to capital A, try to access this instance variables, say A dot pub gives me am public string. Same way, A dot underscore pirb, it gives me an attribute error. It says attribute error, A object has no attribute underscore pirb. This is because double underscore before the variable name makes it as a private variable, private attribute. The same way, a dot underscore prot gives me I am protected. Take one more class, say person, which has protector method, private method, as well as a constructor. And you try to create one object, say person is equal to person with name Ravi, 35. When you try to call this protector method using this object, person dot protector method should give me a warning. It gives me protector method string. Similarly, person dot private method should give me an error. It gave me an attribute error. Person object has no attribute private method. This is how we encapsulate data inside the Python classes. Two underscores before a variable makes it a private variable. One underscore before a variable name makes it a protected variable. It's the same case with the method names. One underscore makes it a protected method, and double underscore makes it a private method, which private methods can only access by this class, cannot be accessed outside a class. So as you can see here, whenever we declare a private variables, those variables can't be accessed outside the class. So how do we set these private variables and how do we get these private variables? So in order to set these private variables and get these variables, we write setters and getter methods. You can see in this class A, it has a default constructor defining two private variables x and y. So in order to get this value x, we write a getter method. Similarly, in order to get value y, we wrote a getter method. In order to set a value of x, we have a setter method. So when you try to run this class inside the Python console, so instantiate an object with arguments 1, 2. So a dot get x should return me a value 1. A dot get y should return me a value of y, that is 2. So in order to set a value of x, we call a method a dot set x, passing an argument, say 3. So when try to get x, it should return me a value 3. This can also be done by using property decorator in Python. We shall go in detail about this property decorator in the meanwhile. You can see here clearly it's a bit intuitive to write a method for each and every variable to get as well as set. So for that we have a property in Python. So property decorator. Python property decorator is one of the built-in decorators. The main purpose of any decorator is to change your class methods or attributes in such a way that the user of your class no need to make any changes to the code. So we have the same class. We will try to do it with a properties decorator. So we'll be having the constructor, and over the get method we'll write a property decorator which will return me the value of x. For the set we'll be having @getX method dot setter, and the method name becomes getX. Similarly, we will also be writing for the getY method. So property This is how we write the property decorator for the getter and setter methods in Python with minimal code change. We'll try to run this Python console. Create an object for this, say a is equal to class, for that a is equal to, try to set 1 comma 2, a dot getX gives me a value 1. It says type error, int object is not callable. Sorry for that. A is equal to gives me a value 1. So we should be calling with a getter method. Similarly, how do you set a value inside this using this property decorators? So a dot get x is equal to, for setting a value we use assignment operator, say a dot is equal to 45. Now try to do a dot get of x gives me a value 45. Similarly, you can also set for get y, say a dot get y gives me a value 2. So a dot get y is set to 54. Get y returns me 54. This is how we set and get using this property decorators in Python. So let's talk one more topic in Python, polymorphism. Polymorphism is an ability in OOP to use common interface for multiple forms or data types. Polymorphism means that different types respond to the same function. Python provides protocols which is polymorphism under the hood itself. So Python internally follows the polymorphism. These Implement consistent behavior for built-in objects for different types. Python is implicitly polymorphic, as I said earlier. So, what are the things in polymorphism we are going to discuss? First one is duck typing philosophy for Python and overloading. Inside the overloading, we shall be discussing about operator overloading, method overloading, and constructor overloading, and overriding, method overriding, and constructor overriding. So, what is duck typing philosophy for Python? In Python, we cannot specify the type explicitly, as you know. Based on the provided value at the runtime, the type will be considered automatically. Hence, Python is considered as a dynamically typed programming language. Let's go to the terminal, Python console. So you can see here I have taken a variable a and I have assigned a value 2 here. What is type of 2? It says integer. As you can see here, I did not mention any type of the variable a. So dynamically Python has interpreted and made this as at runtime took the type of the variable automatically. Same way, say hello. If you do type of a will return me a string, class string. So coming to the Python classes, take one example. Take a Python class duck, where we have methods like sound and feathers, and inside that we have some print statements, and we have also a class person which has methods sound, feathers, and name. So we have written one function in the forest which takes object as an argument and object.sound, object.feathers. We are trying to create one object for duck and object for person. So we are calling this function, passing this object as an argument. So object.sound will go to the Donald. Donald is an object of duck. So based upon the argument, based upon the object we have passed, so it's go to the respective class methods. So for this above thing, this print statement will be executed. So in the forest we have passed John argument. So John is an object of person class. So in the forest, so John.sound will go and get this print statement printed. So person imitates duck. Object of feathers, the person takes feathers from the ground and shows it. These are the two things that will be printed. And you can see here in this function we are passing an object as an argument, object.sound. Based upon the object we have created, it implicitly decided which class I need to go and fetch this method from. So let's try this example in the Python console. Create a class person and create a function in the forest which takes object as an argument. Say create an object for the duck class. Wild, say Donald, and created object for say Ravi is equal to person class. So we have created two objects, one for duck, one for person. So we are trying to call this function passing this object as an argument. Say in the forest we're trying to pass Donald as an argument. So based upon the object we have passed, it implicitly goes and fetches those instance methods. Say in this case we have created object for the duck, so it will go and fetch these instance methods and print these instance methods. So right enter says duck has white and grey feathers. In similar way in the forest try to pass Ravi as an argument, it should print these two things. You can see here these two print statement executed. Let's go to the notepad. So coming to the next topic is operator overloading. Operator overloading, we can use the same operator for multiple purposes, which is nothing but operator overloading. Python supports operator overloading. Let's go to the Python. Let's go to the fresh Python console. Say 1 plus 2, it return me 3. Same way to try to do some add two strings. Say Virat but in this case you can see here we used plus operator, but it concatenated in case of strings, but in case of integers it did summation of those two integers. This is known as operator overloading. Plus operator can be used for arithmetic addition as well as string concatenations. Same way if we take this multiplication operator, so 2 multiplied by 3 should give me 6, whereas a string multiplied with 2 will give repetitive strings, repetitive Virat. So star operator can be used for multiplication of strings as well as repetition purposes. We can overload this operator to work with book objects also, that is Python supports operator overloading. For every operator magic methods are available. To overload operator we have to override the method in our class. Internally plus operator is implemented using underscore and add underscore method. This method is called magic method of plus operator. We have to override this method in our class. Let's take one example. In this example class we have written one class complex with a constructor which takes two arguments, real and image. We have set self.real is equal to real, self.image is equal to imag. So we have written one add method, and this is the one special method which will be triggered when we use this plus operator with these objects. So inside that add method we return one return statement, self.real plus other dot real comma self.image plus other dot. Try to run this in our console. Open the Python console. Try to create an object for this complex class. A is equal to complex, say 1 comma 2. Similarly, try to create one more object. A is equal to complex of 3 comma 4. Try to print addition of two complex numbers A plus B. So see here we have two objects. We are trying to add these two objects. To try to add these two objects based upon this operator plus, will go and hit this add method which is returning self.real plus other.real. So self.real in this case is 1 plus other.real is 3. So 4 comma self.image is equal to 2 plus other.image 4. So it should return me 4 comma 6. You can see here addition of two complex numbers return me 4 comma 6. So addition of both real numbers 1 comma 3 and imaginary numbers 2 4. It's return me 4 comma 6. This is how we overload an operator in Python using a class. So now that we have completed our example, the following is the list of operators and corresponding magic methods. So in order to overload these operators, we need to write these functions in our classes. So plus magic method is underscore underscore add underscore underscore. The same way minus underscore sub multiplies mul percentage mod less than symbol lt less than or equal to le greater than gt greater than or equal to ge methods. These are the special or magic methods in the Python we need to implement in order to overload these operators. Coming to method overloading. If two methods having same name but different type of arguments, then those methods are said to be overloaded methods. Example here, m1 try to pass int a and m1 double b. But in Python, method overloading is not possible. If you are trying to declare multiple methods with the same name and different number of arguments, then Python will always consider the last method. Let's take one example. Test. Let's go to the Python console. Let's try to create one object for this. T is equal to test. T dot m1. You can see here type error m1 missing two required positional arguments a and b. As I said, method overloading is not possible in Python. When you declare methods with the same name and with different arguments, the last method will be taking precedence, and if you try to pass arguments without that, it will throw an error here. So t1 dot m1 and comma 2 should return to arg method. For this case only we have args and k args in Python. So comma star args. Dynamic arg method. You can see here we can declare object, we can instantiate object is equal to test a dot m1. We are not passing any arguments. You can see here it printed me dynamic arg method. In same way a dot m1 we shall pass one argument 1 comma 2 1. Still printed dynamic arg argument. We can also pass a number of arguments for this method. Let's go to the notepad. So coming to the constructor overloading. Constructor overloading is not possible in Python. If we define multiple constructors, then the last constructor will be considered. So we have discussed about that type philosophy in Python: overloading, operator overloading, method overloading, and constructor overloading. Let's talk about overriding in Python. So overriding. Method overriding. Whatever members available in the parent class are by default available in the child class through inheritance. If the child class is not satisfied with the parent class implementation, then child class is allowed to redefine that method in child class based on its requirement. This concept is called overriding. Overriding concept applicable for both method as well as constructors. For this method overriding in Python we use super keyword, super method, super dot method underscore name will call the parent class method. So in Python both method overriding as well as constructor overriding is possible. So in case of constructor overriding, super dot underscore init underscore. So let's try to do some examples. We have a example one class where we have methods like property and method override methods. Inside the property we have a print statement, base class property. Inside method override method we have a print statement, base class method. And coming to ex2 which is inheriting ex1, so all these methods will be inherited to the child class. So we are trying to override this method override, and inside the child class method override method we have a print statement, child class method. Try to run this in the console. Try to open a fresh, ideally. So try to create an object for this child class is equal to ex2 and try to call this method override method a dot method underscore override. You can see here when you try to run this, when you try to call this method, the child class method print statement will be running. Sorry for that, try to run it. without using parentheses. Sorry for that, we need to create a class with using parentheses. That's the issue there. A dot method override. You can see here a print statement child class method executed, and this base class method overridden method is not overridden here. So in order to override this method, we need to use super keyword, super method. So try to redo this entire ex2 example. Inside method override method, we need to call this using super the dot try to run this in the Python console. Try to make it as ex3. And try to create an object obj3 is equal to ex3 and try to call this method override method obj3 dot method override. You can see here, try to call this method override method super dot method override, overridden this entire method as well as printed this child class method. Base class method statement executed and child class method executed. In the same way, we can also have the constructor overloading by using super method. And that's all from this oops in Python. Thank you.